Thanks for and Kelly for inviting me today. As Randy said, I'm going to talk about probabilistic snowfall. We've been doing it now. This is our third winter starting across the region. Here in Sioux Falls, I think we're on our fifth year of doing it, fourth or fifth. And so I'm going to start off talking about verification and then talk about how we can use this in our messaging to our partners and in IDSS. So as Randy, oops, as Randy mentioned, I have done a lot of verification. And the reason is I think it's really important to understand how well this works, because that way all of us have confidence in using it in our messaging. And with the help of a lot of offices across the region, we had over 8,000 snowfall observations to look at this winter, or this past winter, 2018, 2019, and went from over 2,000 forecasts for the fifth period forecast up to almost 8,000 forecasts to look at for the first period forecast. So this gives us a really robust data set that we can use, and we can make some conclusions about how well this is working, and maybe see a little bit some of the biases that are there as well for all of you to use as we move ahead to applying this in our roadmap 2.0, where we talk more about probabilistic information to our partners and to the public. So first of all, what I've got here is I basically looked at the observed snowfall, and then what percentile that observed snowfall would occur, or the snowfall would occur or exceed in the forecast period. So for instance, if I had 2 inches of snowfall and there was a 75% chance of equaling or exceeding that forecast, then it would end up in this bin right here between the 70 and 80%. But if there was only a 25% chance of that 2 inches being exceeded or reached, it would end up in this bin over on the left. And so you can do this with every observation, as long as you have a forecast. So we did that, and ideally you want all these bars, the orange being the WFO and the blue being WPC, you want all these bars to be right up along this black line. That's 10%. Because if you have a really well-performing ensemble, 10% of the time it should be within these 10 percentile bins, or these dectiles. Well, obviously no ensemble is perfect. It doesn't end up being perfect all the time. And what we're seeing are a couple pretty common biases in our ensemble. The first being is that at all forecast periods, we're reaching those rare events, or what should be rare events, occurring less than the top 10 percentile snowfall. We're seeing that occur over 10% of the time at all forecast periods. Now, for the WFO, it's not too bad. It's only occurring at about 10 to 15% of the time instead of the ideal 10. But it's still a little bit higher than what we'd want. And so those high-end snowfalls that we see, that we put on our webpage, the 90th percentile snowfall, that should actually probably be a little bit higher than what we actually are putting out. So in other words, if we raise that snowfall a little bit higher, some of these higher amounts would shift over into the 10 to the 20 and maybe even to the 20 to the 30th percentile. So you'd see these rise up a little bit. The other thing we're seeing is that between 70 and 90% is occurring a little bit too often at all time periods. And what that really kind of means is that our lower end snowfalls are probably a little bit too high at times. That's one part of it. And another part of it may be that because we're looking at only snowfall events, where we knew there was going to be snow somewhere in the CWA, that the probability of 0 inches of snow is relatively low. So in other words, what I'm saying is if we verified this every single day of the winter, probably these maxes here would probably spread out a little bit to the left, to higher percentiles, because you would include those snowfall events where there's really no chance of snow. So that would mean that the 30 to 40 would be higher, and so forth and so on. So this may be kind of what we're verifying implies this at all, or is causing this. And so, but overall, this is actually pretty reliable. And that's what I really want to emphasize, because I've seen ensembles or these type of diagrams where you'll have it hitting between 0 and 10, 20 to 30% of the time, and from 90 to 100, 20 to 30% of the time. And everything else is really low. And we're not seeing that here. So while our ensemble is a little bit under dispersive because we're not quite high enough as we want to be, it's actually still only hitting this area 2 to 5% more often than what it should. So I think you can come away with this thinking it's a pretty reliable ensemble and pretty reliable probabilities that we're using. Another way we can look at this is looking at the middle 50th percentile. So What I mean is, if you think about football with field goal kickers, you want to try and get between the goalposts, right? Well, it's the same way with these probabilistic forecasts, except instead of trying to get in between the goalposts 100% of the time, like you would want with your field goal kicker, we want to get between the goalposts a certain percentage of the time. So if we're looking between the 25th and 75th percentile, which is what we're calling the middle 50th percent here, we want to get in between that 50% of the time. And so that would be a perfect ensemble. So if we look at all our forecasts here, at 60 down to 12 hours, or fit the first period, we see initially when we're out at 60 hours, we're getting in between those goalposts too often, around 70 to 75% of the time for the WFO, a little bit less for WPC. And so basically that means that our goalposts are too far apart. Our 25th to 75th range is too large at 60 hours. But if we go down to 12 hours, we see that as we go down, the amount of time we get in between decreases. And by the time we get to our first period forecast, it's only getting in between those goalposts about 51% of the time, which is really good. I mean, that is what we want to see. I mean, you're not going to get much better than that. What we can also do is we can remove all the zero snowfall forecasts. So we're taking out all the forecasts where the observation had 0 inches of snow. In other words, we're 100% sure there's going to be snow on this day, measurable snow. And when we take out the forecast, then we find out that our ensemble is actually very reliable for that middle 50th percentile. It's actually hitting in there between 50 and 50% of the time for all 5 periods. So essentially, when we say it's going to be between, say, 2 and 5 inches, 50% of the time it's between 2 and 5 inches if that's our 25th and 75th percentile. So that's good news. And we're going to talk about why that may be important later as we get into messaging. We can do the same thing for the middle 80th percentile. That's between the 10th and 90th. Those are the images we put up on the web page. And again, if we look at all forecasts, we see that we're in between that 10th and 90th a little bit too often at 5th period, about 85% of the time. And we're not in between it often enough at first period, closer to 75% of the time. So you see that same decrease. In this case, you also see WPC is a little bit higher than us. And that has to kind of do with the technique that's being used to put our forecast into the WFO forecast into the ensemble. So you go from being too wide to too narrow by the time you get to 12 hours. We can, again, do the same thing and remove all those 0 inch forecast, those no snowfall observations. And when we do that, what we find out is that we're not getting in between the middle 80th percentile quite often enough. It's generally around 70 to 75% for all 5 periods. And so what this kind of means is when you look at those graphics, and I know a lot of people, and it takes a lot of getting used to because they look very wide, but in fact, they're probably not wide enough. They probably need to be a little bit lower on the low end and a little bit higher on the high end to get the goalposts wide enough when snow is expected. And so that's something to keep in mind, is although they look wide, they're actually a little bit under dispersive. It should be wider than what we're seeing. Another thing you can do also is you can look at how often the range, what the frequency of different ranges are in the forecast. And what do I mean by that? So we can take the difference between the 25th and 75th percentile, which is what I've got here, and we can subtract them. So if the 25th is 2 inches and the 75th is 5 inches, that would be a range of 3 inches. And we can say, okay, what's the range for different deterministic forecasts? So on the upper left, I have all the 0 to 1 inch deterministic forecasts. And we look at the ranges that you can get for all the different probabilities. Those ranges can be anywhere from near 0 range all the way up to one forecast had a 14-inch range. But if you look at the box, that is our middle 50th. The 25th is, that is, the top of the box is 75% of our ranges are basically less than 2 inches, which if you think about it, for a normal 1-inch forecast, that's about what we go for a range. And that actually drops by 12 hours down to right around 1 inch. So most of the time, the difference between the 25th and 75th percentile is about the same as the range we've been telling the public for years. But there are those rare cases, 10 to 25% of the time, where those ranges can be very large. And we'll talk about why that is in a little bit and what that information may be telling us that we could be very valuable to our customers. If we look at 3 to 4 inches for forecast, deterministic forecast of 3 to 4 inches, you can see the ranges again are pretty close to what we normally use, right around 4 inches at fifth period, dropping down to around 3-inch range by first period. And you see the same thing by a 6 to 7 inch deterministic forecast. So what we see about the difference between the 25th and 75th percentile is one thing is that the difference between them gets smaller as the forecast approaches. And so what that means is that hopefully we're actually zeroing in on what the actual snowfall is going to be. We're narrowing that range. The other thing you see is that as snowfall forecast amounts increase, the range also increases. And that makes a lot of sense as well, because usually you have that zero lower bound on snowfall. You can't get negative snow. So that kind of puts a stop to how low you can get. So when you only go an inch of snow, there's not going to be a lot of members that are going to be much higher than 2 inches in most cases. But there are going to be a lot more members that are around 0 inches. So, but as you get higher and higher up, you can have more and more values that are less than the forecast because you have that difference with zero increases. And so we see that the range increases with increasing forecasted snowfall. We see that the range decreases as we get closer to the storm. So we're going to talk about why that's a little bit important, but that's kind of what the gist of the verification has shown. But the probabilistic stuff that we do isn't really valuable unless we can share it with the public in a way that they understand. And so how do we do that? Well, here in Sioux Falls, 3 or 4 years ago, we came up with a communications plan. And the idea is that we wanted to have a plan in place on how we talk about initially winter storms, but we also apply it to summer. And so we start off talking very probabilistic early in the event when the storm is 2, 3, 4, 5 days out. And then as the storm gets closer, then we begin to get more and more deterministic so that by the time the storm's on us, we're talking about specific snowfall amounts, specific timing, and we have very little probabilistic information. So Grand Forks and Bismarck took this plan and said, well, instead of having time periods assigned to it, like 3 to 8, 48 hours or greater for outlook, etc., why don't we assign it by confidence? And what do I mean by confidence? Basically what I mean is how confident are you that the snowfall you're seeing from the NBM or from the EC or from the GEFS mean, how confident are you that that snowfall is actually going to occur when the storm occurs? And so initially, if your confidence is very low, you want to be, again, very broad wording. And then as your confidence increases, you get more and more deterministic. You start bringing in more and more information that refines the storm and tells people exactly what's going to happen. And so, right now, this is more of something we can do internally with ourselves to kind of calibrate it. But the real reason to start doing this is so that we don't jump around in how we message a storm from probabilistic to deterministic, back to very probabilistic, back to deterministic, because that will confuse our partners. We want to make sure that we're following a smooth road as the storm comes in. So how does this work? Well, one thing we can do is we can take the probability of exceedance, which is produced and on our web pages, and we can define a snowfall potential map. And how do we do that? Well, basically, WPC has been doing this for several years. They have a snowfall potential or snowfall risk of greater than 4, greater than 8, or greater than 12 inches in 24 hours for days 1, 2, and 3. And they said that if there's a 10 to 40% chance of that, it's a slight risk, 40 to 70 is moderate, and greater than 70 is high. Well, we changed the risk wording to potential because risk implies a threat, and snow by itself is not a threat. The impacts of that snow are a threat. The snow by itself is not a threat. So we've changed the wording to potential. And so you can put up a potential of difference of, say, 6 inches like we have here. And you apply the same slight, moderate, high with the same percentiles WPC does, except we do it for an entire storm rather than over 24 hours. And so this allows us to talk about snowfall amounts in terms of a floor a lot of times. So instead of saying 4 to 8 inches or 6 to 12 inches and people lock on to that higher number and it kind of snowballs into a hype, we can sit there and say, here's the potential for 6 or more inches. So, if you're in southeastern South Dakota, southwestern Minnesota, there's a high potential of that. But if you're in northwestern Iowa, you're probably not going to get that 6 inches of snow in that area because the probabilities are low. And we can also, either have it just the category similar to what SBC and WPC does, or we can add percentiles to the graphic like we've done on the left. And we actually went through and showed this graphic at an IWT 2 weeks ago, and they really liked our partners like seeing the percentiles. It was by far the most popular one we've done. And something that we're going to begin doing in our sit reps for our partners to share not only the categories for those who aren't comfortable with probabilities, but also show the probabilities for those who have more experience with probabilities and percentiles. So it helps them in their decision making. Another thing you can do with probabilities of exceedance is what Grand Rapids did here. Use it as a way to focus the public into an area that may have the worst impacts from a particular storm. So on the right, they put a graphic of the chance of greater than 6 inches of snow. But they use the direct percentiles there as reference for the public. But they don't sit there and talk about, is it going to be 8 or 10 or 2? They sit there and say, well, here's our worst impacts, and here's what the impacts are. So they drive use the probabilities to help drive their impact statement. Dangerous travel, multi-days delays, etc. So you can use these percentiles to also help you focus where the impacts may be worse for a particular storm. Another thing we talk about is snowfall ranges on graphics. So as all of you know, the ranges are determined specifically by the color bar on the left. That's what determines whether you're 8 to 12 or 1 to 2 is what color you are. But the public doesn't really know that. And so if you're Rapid City here and you've changed your forecast from 11.9 to 12.1 inches, what the public sees is that you've changed your forecast from 8 to 12 to 12 to 18 inches. So what was basically a very little change in the forecast, from a public perspective, seems like a significant change. Suddenly they go from less than a foot to greater than a foot of snow. But really, in reality, there's been no change in the forecast. And this has happened elsewhere too. It happened in New York City, I believe in 2016, it may have been 2015, where they made a change from 18 to 24 to 24 to 36, and people freaked out. And it had nothing to do with that their forecast had a significant change. It's that the color bar changed, or what color bar they were in. And so this is a problem because you're giving the public and partners a perception of a large change that may not occur, and you can't really explain it very well to them in a graphic. So what Grand Forks did, and what Tommy Grafenauer shared with me, was from the storm. This is from October, a month ago, the storm up there. And they used the 25th to 75th percentile range on their graphic instead of the color bar range. So if you look to the west of our circle here, you can see that the ranges are fairly similar to what we got on both of them. It's about 10 inches around 10 to 12 inches in this heavy snow area around Devil's Lake up towards Langdon. And here it's either 6 or 12 inches. So pretty similar, what we've been saying. But if you go farther east here into the Red River Valley, the ranges are much different than what we're used to seeing. So for instance, in Boston, you have 3 to 4 inches, whereas if you use the 25th to 75th, it's 3 to 11 inches. Well, is that wrong? Or is the 3 to 4 inches wrong? There was a lot of uncertainty in precipitation type with this storm. And so some of the ensemble members produced all snow. Other ensemble members produced all rain. And so you ended up with this very large range in the Red River Valley because different ensembles were producing different precipitation types. So what this 25th to 75th is giving you is a sense of, basically there's a lot of uncertainty in this forecast. So can we convey that? Could we use this to convey that to our partners? And remember, based on the verification before, we're going to still be wrong 50% of the time in this with these ranges, because we're only between the 25th and 75th. Having said that, I do realize this is a huge change. We showed this at our IWT as well, and there was some concern about going with really large, unusual ranges that the public hasn't seen before. Well, they see a 1 to 12 and go, well, you guys don't know what you're talking about. So I think we should move in this direction. I think the statistics support doing this, but I think we also have to think about how do we message this. It's not something we can roll out without any explanation. It's something that we as an agency or as scientists have to sit there and how do we explain this to our partners? And maybe we just show this to our partners, or do we show it to the public? But how do we explain it to them so that it makes it understandable to them? We can't just put this out there with no explanation because we'll just confuse them. But it does allow you to put out more information in one graphic than the color bar range does, which is advertising much more certainty than actually existed with the storm at this time in the forecast. Another thing you can use this data for is actually setting a goalpost. So in Colorado, they will put out the 1 in 10 chance or the high end amount of snowfall in all their sit reps to their DOTs. And why do they do that? Well, they work with their DOTs to show them that this is giving them the worst case scenario or a near worst case scenario. And not everywhere is going to see this amount of snow, but the DOTs understand that while not everywhere could see the snow, it's a snowfall amount they may want to prepare for in case some places do get to that high end amount. And so every single time they put out a package to the Colorado DOT, this graphic is included in that package. So they work with their partners to include probabilistic information. You can also include it in a sit rep, but you may want to consider then including physical reasoning, especially if there's a large spread. So this is, again, the 10th, 90th, and most likely snowfall. But in this case, this is from our storm last April. We included reasoning as to why maybe the 10th percentile could occur, or why maybe the 90th percentile could occur. The high end amount could occur. And when we showed this graphic at our IWT, we showed it first without any explanation. We just said this is the high end, low end, and expected. And it was almost unanimous that people thought that that was too much information. They couldn't make sense of it. They would not want to see that. But when we added the explanation into the graphic on the next slide and said, what do you think of this? Is this useful? Most of them agreed that in that case, it was useful information that they could use. So including that type of physical reasoning to your partners, if you include a 10th and 90th in a sit rep, can be valuable for giving them an understanding of what the uncertainty is in the forecast and why that exists, and what they can look for in future forecasts that may lead you to either less or more snowfall in a particular place. Lastly, we can also begin quantifying uncertainty using the probabilities. So this is a distribution of the 10th and 90th percentile snowfall difference. So it's like what I showed earlier, except for first period, and we start at 0 to 1 inch deterministic forecast up to greater than 19 inches. And the top of the box, again, is the 75th percentile of the distribution, and the bottom of the box is the 25th. Well, if everything verifies exactly the same, regardless of what the differences between the 10th and the 90th, then what we can say is as the difference gets larger, the uncertainty increases. So why don't we define anything that's greater than the 75th percentile as a less certain forecast or a more uncertain forecast, and then anything less than the 25th percentile in range is a more certain forecast. So if you do that, you can actually come up with an equation for the line, and you can come up, this is just made up data, but you can have the forecast snowfall, the 90th and the 10th percentile. And you take the difference between the two and then find out where you are in that distribution. You can define then within the storm where the snowfall is more certain or less certain. Basically, you're looking at the confidence interval and looking at where it's unusually large or unusually small. As you can see here in our gradient, we're less certain in the forecast, which is what you'd expect because small changes. Most of the snowfall has quote unquote normal certainty, and then we're not expecting any snow is actually more certain because it looks like we're expecting there's no chance that cold air could get that far southeast to produce snow. So here at Sioux Falls, we're not going to put this out to the public or anything like that, but we want to use this internally to kind of see if we can get a better understanding of where it's more and less uncertain snowfall. And interestingly, at times you'll see whole storms will have less certainty because the track keeps changing so much or whatever, or temperatures change, and whole storms will have more certainty. So it's not just particularly within a storm, but even different cyclones may have different amounts of forecast certainty as you go through the year. So again, probabilistic forecasts are fairly reliable, and if you know the biases, it can help you in messaging. And again, the middle 50th percentile is very reliable. The middle 80th percentile is a little under-dispersive and probably needs to be a bit larger, especially if snow is going to occur. Again, tailor your message for your users. For EMs and DOTs, percentiles may actually be heard by them because they're familiar with risk analysis. The public, on the other hand, may not be as comfortable with that. And you can, in that case, you can talk about snowfall potential using the probability of exceedance, to help the public understand what the potential for different snowfall amounts are. And also, finally, if you use the 10th and 90th percentile, consider providing physical reasoning to help your customers understand why you might get less or more snow than what you're forecasting. Finally, I think we need to start considering using the 25th to 75th percentile snowfall as the range under deterministic snowfall plots rather than that color bar range. Again, it's not something I think we can do right now, but I think it's something that we start planning for, starting to use this information to our advantage to message uncertainty better, and also so that small changes in the forecast where you cross the color bar doesn't get a perception of a large change to the public when they see that snowfall range change. That's all I have. So if there's any questions, and thank you again for allowing me to talk.